For this assignment, most of the lines has been commented with a concise explanation and well spaced with appropriate variables and function names. I will quickly go over the lines that in my opinion was well designed and explain them in this video. For test 5, get edges, I used two for loops, one for looping over the rows and one for the columns in the adjacency matrix. If the element at the two indexes are adjacent, the element at that index will be stored into a string variable and added as a pair into the edges vector. For test 8, remove vertex. There was a mistake with the comment on line 219. It's meant to say columns instead of rows, so I'll explain it. I use the auto variable to store the result if the vertex that needs to be removed exists. The function proceeds to remove the vertex only if it exists. By finding the index of that vertex, then I loop through every row in the adjacency matrix, and by adding the index to the beginning of each row, it will ensure that I'm only erasing the values at that column. Same goes for erasing the rows, but without the loop. For example, if I were trying to remove D, it will be at the index of 3, which by adding to the index of the row, which is incremented by 1 each time, it will erase the element at each column of that index for every row. For test 9, the depth-first traversal, instead of using a Boolean variable to mark if a certain vertex has been visited or not, I used a set of strings, then a for loop to loop all the adjacent vertexes of that vertex. A Boolean variable is used to determine if the vertex exists in the set of visited vertices. This process repeats until all the vertices has been visited. And before every loop, the current vertex will be added into the results vector. For test 10, I used a vector of booleans to mark if the vertex has been visited or not. Then it is pushed into a queue. While the queue has vertices in it, the current vertex is stored into a string variable, then the size of the queue is decreased by 1. I've also designed another function which is used to return the index of that current vertex, which is used to check if the element at that index has been visited or not. If it has not been visited, it is added to the results vector and marked as visited. For all the adjacent vertices of that current vertex, it is checked again to see if it has been visited or not. Then it is pushed into the queue. This process repeats until all the vertices have been visited.